A very good morning to everyone. Today I would like to present about Lagrange interpolations. So what is Lagrange interpolation? By theory, is given n distinct points x1, x2 and until xn and n values c1, c2 until cn. There is a unique polynomial fx of degree n minus 1 such that fxi is equal to ci and the I is greater than equal to 1 and less than equal to n. And in fact, the fx can be written as this formula, which is a sum from I equal to 1 to n and ci multiplied by pix. And this pix can be written as this formula, which is a multiplication for j greater than equal to 1 to, and this j is smaller and equal to n, and also z is not equal to I. And the multiplication is this formula, which is x minus xj over xi minus xj. So these formulas can be written in this form, which is j is greater than and equal to 1, which means that j starts from 1. So we can substitute this j into 1 and it goes on multiplication until I minus 1 and then to I plus 1. This is because j is not equal to I, so I is not included in this multiplication. Then it continues to go on until n. So this formula is formed, but it seems like it's too complicated and hard to understand, right? So I'm going to explain it in a more simpler way, and then you all will have a better understanding about the Lagrange interpolations. So how does this Lagrange interpolation works? Actually, it's very easy. So assume that we have 3 points x1, x2 and x3, which have the values fx1, fx2 and fx3. And this formula actually can be written in this form. So how can we know this? Actually, it's very easy to form this equation. Let me explain to you all. First, we need to focus on the first part, which is this expression. So how can we form this first expression? It's very easy. Just need to take the values of the points that we taken, which is x1 and which is the fx1, in front of the expression. Then we multiply it by x minus the points that we didn't taken, which x2, multiply with x minus the other point that we never taken, and divided by the points that we take minus those points that we didn't take. So actually it's very easy to form this first part. We just need to assume that we take a point and substitute the values of the points that we take in front of the expression, and the upper part of the fraction is just the unknown x minus the points that we didn't take and divided by the points that we take minus the points that we didn't take. So it is also same with the second part. We just substitute the values of point x2, which is fx2, and the upper part is x minus x1, because in this second part we take the second point, which is x2, and x minus x3 over x2 minus x1, x1 minus 3, and plus the third part, which is the values of the third point, fx3, and upper part x minus x1 and x minus x3 over x3 minus x1 multiplied by x3 minus x2. So why does not include the points that we taken in this point? If we include x1 at here, it will become x1 minus x1, and the denominator part will become 0. So anything divided by 0 is infinity. So this expression cannot be calculated. So the only thing to form this equation is to solve it part by part, and we need to take the first point and the value of first point and substitute it into the first part. The upper part of fraction is just using the unknown x minus the other points that we didn't take and divided by the points that we take minus the points that we didn't take. So I think that you all will have a better understanding about the Lagrange interpolation now. So let's look through the example. Example 1. Find a polynomial fx at most degree 2 such that f2 is equal to 3, f3 is equal to 2, and f5 is equal to 1. So from just now, we know that the formula of the equation is this. So it's very easy, just same with the method I taught just now. First, we look through this point, which is x2 equal to 3. Then we look through this first part and ignore these two, the part behind, and we need to substitute the values of the points that we take, which is 3 in front. Then the upper part of the fraction is we use a unknown x minus the other points that we didn't take, which is 3 and 5. Then the lower part of the fraction is the point that we take, which is 2 minus the other points, which is 3 and 5. Then for the second part and third part is also same. Then we can form this formula and we can simplify it into this form. Then become x minus 3 multiplied by x minus 5 minus x minus 2 multiplied by x minus 5 plus x minus 2 multiplied by x minus 3 over 6. So now let us look through another example. Find a polynomial f1 at most degree 2 such that f2 equal 3, f3 equal 2, and f5 equal 1. So actually this example is similar with the problem just now, just that we need to find a polynomial f1 instead of fx. So from example 1, we know that this is the formula that we find. Then what we need to do is we just need to substitute this x equal to 1 into the equation obtained from example 1. After we substitute, we can obtain this equation, and after we calculate it with a calculator, we can obtain the values of f1, which is equal to 13 over 3. Actually, this Lagrange interpolation is not hard for us to learn, and actually it's quite easy if you know the sequence and the method that they arrange and form the formula. It's not hard. So I hope that my presentation will let you all to have a better understanding about Lagrange interpolations, and that's all for my presentation. Thank you.